Okay, first of all, sorry to the stream people. That was not 1:15. Let me blame the pizza and the students that ask questions. So we appreciate questions at any time, of course. So yeah, so what did we talk about? Ah, no, we didn't talk about any of that. So we talked about services a bit. Right, so yeah, you identify how your service should be run, right? So you determine the service behavior independently of the calling activities. So the service can decide whether it should be restarted, not, should just die, should be restarted with the same intent, in short, initialization parameters or whatever else, and how it would live. But something we want to talk about, I think, should be talked about, and if it gets too boring, you can stop by throwing tomatoes. But the idea of priorities, because I think there's a common misconception that foreground means higher priority than background and so on. So that's to some extent true, but only laterally, and that's why I think it's worthwhile losing a few words on that. So the idea is that the Android priorities roughly are structured in that very same fashion here. So we have foreground processes followed by some sort of visible processes, service processes, background, and nothingness. So we don't care about the bottom bits. The interesting part is on top. But the most important bit is that it actually doesn't manage application components. It actually manages processes. So priorities are associated with processes, which of course contain one or more application components. So, and the idea here is that different priorities exist for different of those application components. So your foreground activity is obviously considered of highest priority, but it also includes all the processes, all the application components that are bound to it. So it would be a service that is bound to your application of activity, as well as a content provider, for example. As soon as they're unbound, then the situation is obviously different. Then it's only the activity itself. So it's quite important to bear in mind. So in fact, also seemingly background application components can have foreground priority. Similarly, the foreground service that I mentioned before, that doesn't necessarily have an activity active, for example, your media player and so on, they also running with the highest priority, because you want to ensure that your music is played without disruption or whatever else, even though it's not doing anything but well, still playing music, but not much else. And or slightly lower are visible processes. So that sounds counterintuitive. So visible processes can have a lower priority than foreground processes. So any intuition what a visible process would be? Do you have a good example?
Home screen.
Yeah.
So if you're playing music in the foreground, you don't see it, but it's the higher priority than your home screen, which is a visible process.
Yeah, but visible as in visible on your screen. Yeah, right. Yeah, because it's visible, right? Yeah, it's cool. Yeah. So yeah, the other one I found is like the permissions dialog. So even though it's in the foreground, it doesn't have the highest priority. So it's also just showing it, click it away, whatever, right? So or not. But that's similarly a visible process. If the system runs out of juice, it will discard those first before your actual high priority process. Yeah. So again, visibility doesn't imply priority necessarily. It correlates, but not really. It's not a one-to-one match there really. Okay, and of course, then as the service processes come next, those would be services running in the background that are not directly linked to any foreground activity, that are have their own managed runtime, but actually not bound. For example, if I just talked about the onStart command, which is to start sticky, those processes that would be restarted after they have been killed, they would run as those service processes, I believe. Note, however, once you run, as long as you run onStart command itself, it's a foreground process with highest priority. So once this method is actually executed, as long as this method is executed, they have highest priority in the system. So the idea, why would it make sense to give highest priority for a service that will run in the background during initialization? Any intuition? That's the only reason really. So so it's not black and white, the whole thing.
Yeah, when the activity starts a service, usually it needs it. as well. So
Yeah.
you know, giving priority to the activity and the UI without the service actually initiated it's counterproductive, right? So you want the service to actually boot so the activity can continue, even though those things happen asynchronously.
Cool. And then the last thing would be background processes. That's basically services that have stopped but haven't been discarded. You guys know that from your phone. If you look into this menu, you see all the running applications and all those magic cleaning applications that you download and you press the boost button. The only thing they basically do is discarding all your background processes, which would be otherwise still lurking in your memory. But if you were to choose them again, they would just be available faster. Yeah.
My previous Android phone would stop, like the UI would stop working after a while if I didn't discard the process and press the boost button.
That's interesting.
It did not have enough memory and the OS did not account for this. So the UI would become extremely laggy after a while.
So was it rooted, or did you run your own?
No, it was stock. No, it wasn't stock. It was running another ROM from the factory, mind you, but it was running Lineage, I think, because it's higher performance than stock Android. So to account for the slower hardware, they just installed a custom ROM, which also didn't handle memory good enough.
Interesting.
No, not a good combination.
They probably didn't initialize the Lineage, ROM properly, with respect to the hardware specs, I guess.
Maybe.
So it's the threshold values or whatever else. I don't know. So, but if the fact that you have Lineage OS means you definitely don't have a stock ROM running, So it's like quite involved. Okay, cool.
Side note to this, you cannot do anything with the UI from non-visible processes, which is counterintuitive often. So for example, from your service you cannot show a dialog box. From your async task you cannot show progress bar. From whatever you're not doing outside of your UI thread, you cannot do anything with UI.
You have to send it to the UI.
Yeah, you have to communicate with the UI thread to update the UI basically.
Yeah.
And it's a bit of a pain in the ass. So what you can do is you can display toasts from anything.
Toast is easy.
Toasts are not considered UI elements. So toasts are easy, and you can show toasts from your service or async task or whatever you want.
So it's a good debug tool actually. If you want to get something, you want to screen up or not, I think. So
but apart from a toast, you're doomed.
Yeah. That's right. Notification, you need to start them before, right? As well.
Yeah.
That's right. Okay. Cool. Sweet. Anything else? Empty process is not something we can be concerned with. That's operating system leak. Is there anything else to mention? Priorities, got it covered. Permission, that's a visible activity but not high priority. So not sure why I put this in, but this is probably more relevant. Okay, so to implement different service types. So we talked about foreground service has high priority, but actually seemingly doesn't have much visible other than a persistent notification. We have services that deal. There's one other challenge is, and I think that has been brought up already in the break right now, is what happens if you have multiple invocation of the same service, right? So for example, by different activities, which is entirely possible. Again, recall that in Android, the application components are packed as part of an application, but they may also be invoked by non-application application components. Does it make sense? No, basically by other applications. They can use part of other applications, which is pretty cool and very different from iOS, I guess. So, so if you do that, but you also need to account for this, obviously, because if multiple intents can be sent to your service at the same time, you may run the risk that you actually have multiple execution of the on start command, at the same time potentially. So. And by default, you need to deal with yourself. So you need to anticipate the fact that there may be requests untimely coming into your on start command. Is there any way of synchronizing on start command?
No.
No, right? You can't use synchronize, right? No. The signature is fixed, right? Okay. So you need to do it yourself. But there's one way you can deal with this by using an intent service. It's a specialization of a service. And it will ensure that the incoming requests to your service are queued and executes sequentially, right? So you lose the benefit of potentially doing multi-threading in that. Well, you can do multi-thread, you can spawn up a thread for whatever else, but you can't operate on the input requests at the same time. So you actually need to do it sequentially, but it gives you the benefit of simplicity, that you actually don't need to deal with all that synchronization problem at the same time. And of course, the regular service would be simply multi-threaded, so you can't control the number of, well, you can't control the requests coming in, but you need to deal with the synchronization of it. Something we probably need to put it in a session on synchronization, right, in Java?
Yes, we should have a
now in retrospect
lecture on it. Yes.
So we make it a dedicated session. That probably makes more sense to cover all the aspects. Also, we need to cover intents as the essence comes. Intents and intents filters. We just were very implicit about it. Yeah. So we do that as well. But looking at the different services, the third aspect is the bound services. Bound service, and that's the nasty one. As I mentioned before, so it basically lives with the activities that are bound to it. And the idea is there that you have kind of a direct interaction with the service, and you do that by implementing what's called the onBind and onUnbind method, right? So, and this basically is your way of interacting with this. I have an example of a service I can show, but it's like really, I don't know, if we probably don't have the time to go into that right now. I probably should we put it in a dedicated session, the binding of services, or not?
Yeah, yeah, we should. It's kind of a complicated.
It's a bit complicated. It's going beyond the create a service, do some stuff, but you actually need to deal with writing intermediary classes and so on to actually handle that. So it's quite a bit nasty to do that.
So I think last year and 2 years ago, no one was using bound services. People were using the intent services and normal services. And having that under your kind of belt is enough most of the time. The bound services, it's a very specific situation where you have a long-lived process in the background that you need to reconnect to from a killed activity. So you may need to do that, but for most use cases you don't need to do that.
Okay. Cool. Well, so one of the aspects in terms of services, we only talked about the basically obviously implementation activity, but as with all other application components, they need to also be registered in the manifest. So you recall that we did this for content provider, we did this for activities, and the same for services here. And those are the possible attributes that we can provide. Obviously, some sort of description. Should the service, for example, be started at boot time, I believe at boot, direct boot aware implies, if a service is started before the user actually logs in, so before you unlock your screen or only afterwards, if it's enabled or not, and exported implies that another activity that's not part of your application can invoke that service. So if you export a service, you need to expect other application components to invoke your service, potentially, right? Third-party applications. If you set it to false, it's not possible. Yeah, the rest is isolated process. Yeah, the question is whether you want to run your service in a dedicated isolated process. So that's how you parameterize it here. So label, name. Permission is interesting. It's basically the permissions that are necessary to access this service. So if the user or if a particular application doesn't, the client application, the one that wants to access your service, doesn't possess those permissions, then it will not be able to invoke your service, right? It will reject it. So yeah, that's the idea there as well. And you can give it a named process name, so it's actually identifiable in your debugger. So you figure out easily what your service is. So that's the key things that you specify in the manifest, basically. But Gradle is usually quite somewhat helpful. It actually does it for you, but only in a very bare bones sense. Hang on, bring up the service example again. So if you create your service, basically you have those entries, in this case enabled and ported, and the service that's the name that's then appended to the package, so to the actual package of the application. So yeah.
Yeah, so in that case, it will run in the same process as the main
That's right.
activity, and if the user kills the activity, the service will be killed as well. And if the activity goes into background and is wiped by OS, the service will be wiped too.
But if you set that here to true, then it's separate, right?
That's right.
Yeah. Cool. Good. Right. We are probably running out of time here a bit. But okay, foreground services. So the only differentiation of services in terms of foreground and background operation is to that they actually need to show a persistent notification in your UI. So it's one of those you can't just clear away, so that will persist, like your audio player generally, right? Unless you press pause or something, you'll probably get rid of it. But if that's not the case, you have a notification, and any service that's associated with this notification is considered a foreground service and will be treated with high priority. So, but yeah, that would be roughly the syntax to actually set up the notification for that particular service, and then you would call start or foreground here basically to initialize a foreground the foreground service. So I think I summarized all the differences between the service types here. So if you want to look at it and play with this, foreground services are started with start foreground, but can kill themselves or then be killed from the outside using stop service. And for single-threaded and multi-threaded service, the only difference is the class they extend. In this case, the intent service to have a single-threaded execution, but the rest is the same. And for binding, it's simply the bind functionality that needs to be considered. But that's basically how you control it. Yeah, we leave that for another time. That's not gonna work well. Good. So network connectivity. Yeah, we're running out. I go a bit into it, I guess. Then we need to continue it afterwards.
Yeah. So one comment about the services. So the foreground service is kind of carefully managed by the operating system. So the operating system will not kill it. It will kind of treat it as an activity, as a foreground activity. If you don't set it as foreground, then it is sort of connected to the activity. So as soon as the activity lifecycle kind of destroys it, then the service will get destroyed as well. So that's kind of useful for like trackers or something you do in the background. You have to kind of make it sort of a foreground service. And the reason why you inform the user that it's something running in the background is by this notification icon that Chris just described. But you can do it with the multi-threaded service or with the single-threaded service. So the concept of foreground service is kind of independent of the class that you use. And then the single-threaded one, you can reinitiate. You can kind of talk to while it's running by issuing start service again. And it's not starting a new service, it's just, the call will get to the same service that you have, and it can redo some or restart some of the tasks. So that's the main.
Good. Next lecture.
No, it's the survey.
Okay, I thought I'm missing something. First exam during my class. That's pretty cool. So can't have enough of those.
Yeah. So I kind of let the master students do the survey for the last few minutes of the class.
So we continue, or is that over now?
Yeah, I think it's over.
Okay. All right, no networking then. Such a pity. Oh no, one slide perhaps.
Ingen fra Institutt for Design her, eller? Nei. Ok, jeg kan vel sammen skjemaene. Beklager. Det var ikke så lett for dere å fylle ut dette her. Sorry.
No, that's all good. Interesting.
Okay.
How long is the network part?
Long.
Yeah.
I can show him two things. One of them the permission bit and volley.
Yeah.
Because the actual network is a nightmare.
Yeah.
Oops, I shouldn't have said that. It's long.
So let's do the permissions. And let's leave the rest until Thursday maybe.
Okay. Okay, do it right. Yeah, okay. Yeah. Okay. Right. All right. Cool. All right. Now that we have all filled out the survey, so networking. So why do we come up with networking here? Well, number one, because it's obviously relevant for your assignment or your labs rather. And the other aspect is obviously that it's a long-running task. So it's a prototypical I/O activity on surprise, mobile devices, right? So so it links it back to yesterday's lectures, right? Well done. Oh, okay. Anyway, right. So anyway, we have networking is something to talk about, and the issue you get if you do network in a main thread, you get some sort of exception, so at least some sort of info or whatever else in the console, the logcat that we just saw right before when we were doing thread sleep. And the key thing is there that most people will struggle with first is the permission set. So because you need to actually tell every application that they actually have access to network or the internet rather. So it's quite important to get that right. And by default, the thing that you generally want to have is the permission to use the internet. But if you want to assess the state that you actually can access, the internet, or want to figure out what resources you're connected to, you also need to give further permissions, such as the access network state or access Wi-Fi state permissions, because they are fundamentally living in two different managers. So the stuff you see on top needs to go into your manifest. So you basically tell in the manifest, okay, this application, including all its components, should be able to access the internet, but also access network state. And anytime you want to do something, or before you don't do something that's network related, you probably want to check that you're actually connected, right? The worst possible application is the one that assumes anything, and and then you are in for trouble, because realistically you won't always have network connectivity. You will find that more than often once you start loading your apps onto your device for the first time. And that's basically how you do it. As I mentioned before, in context of the services, you just call get system service in your activity, for example, right? So it's available in your context. And then the service of choice, in this case, it's the really connectivity service. And then you can access the active network info. And active network info will give you the info of any network or the currently active network. Could be a mobile network or Wi-Fi or anything else, right? So you have multiple means of connectivity. But if you want to be more specific and, for example, want to check out that you're actually connected via Wi-Fi, you can check the network info type in this particular case, and it should equate to type Wi-Fi, as opposed to what other do we have? Generally, when you want to explore anything like this, it's probably not good wasting too much time remembering of it, but generally exploring the constants that are part of the do what you want. As long as I'm not involved. Yeah, this broken, sorry, it's broken project. AsyncTasks, lose my AsyncTask here. That's right. So connectivity manager, get the active network, get active networks info, get all the networks that are available at a given time. Enjoy your weekend. Anyway, so basically you can explore the constants and figure out what the different types of networks that are available. So connection manager, top type, whatever else. If you want to access the Wi-Fi manager, which we don't do here, so this is just connectivity. If you want to access Wi-Fi, Wi-Fi implies things like strength of the signal, SSID, encryption, any of the metadata related to your Wi-Fi connection. You need to also have the permission access Wi-Fi state, right? So it's quite important if you want to differentiate, because if you just check for internet, you may just be on your mobile data right now, right? So it's quite relevant. Yeah, cool. So Android offers obviously socket-based programming, as we know from Java. So if you have a Java library that uses networking, you can probably pretty much use that out of the box, and you have support for the advanced network functionality. So the NIO and NIO2 that were added in later Java instances. But and this is something I would have wanted to have a look at it, how to do it in Android properly, including asynchronous tasks and so on, but we probably won't have the time. And you find that it's actually fairly low level, fairly involved. And then there's increasing number of third-party libraries. And similar to the Room library for ORM in the context of persistence, there's also de facto standard for third-party libraries to be used for networking. It's called Volley and has been introduced in Google I/O 2013, I believe. And it's actually quite straightforward in terms of its syntax, its use case. So if you want to do simple things like retrieving XML-based data or feeds or whatever else, that's a good starting point to look at it. But we'll probably, we'll have a chat about it more on Thursday, briefly. Just to tell you, briefly show how tedious it is to do it actually natively, and then how too nice it is to actually use libraries as well. But we won't have the time to dig into it right now.
You can use it for describing the Gradle and libraries as well. So we can use Volley as an example of doing that. But
it's basically just one dependency you add, right?
Yeah.
It's like super simple.
Yeah.
Okay.
It's kind of a word for dependency.
Yeah, exactly. That's right. Oh yeah, okay, okay. Cool, sounds good. Well, with this, thanks for surviving. Well, the ones that did anyway. I'm not sure how many didn't make it. But I'll drag them out afterwards. But yeah, enjoy your weekend and happy hacking, I guess, on your mobile assignment.